All right. All right. Good evening, everyone. Welcome to the Data Science SG Meetup together with GovTech. So we have the pleasure today of having GovTech to share their data science work. But let me just set up some house rules also with you all. So just be reminded that the webinar will be recorded. So to make the experience enjoyable for everyone, right? Please note the following. Respect the speakers and the audiences. We do encourage open and healthy sharing of the views. So you can put in your questions under a Q&A. You should see a Q&A at the bottom of your Zoom screen. So you can click on that Q&A and post your question over there. Okay, submit your question using the Q&A function. When you're granted speaking privilege, right, please turn off your webcam and do not share your screen, okay? So do take note of that. So I'm going to show you now the schedule for tonight. Okay, so we are happy to have Cheow here, the Government Chief Digital Technology Officer, right, to do the opening remarks. Then after that, we will have Bertrand, who is a Smart Nation Fellow with GovTech, to share about intelligent citizen assistant. I think it's a chatbot from I remember. And last but not least, we will have Delon, right, to share on VigilantGantry. So I'll let him share the details with you all as well. So with that being said, right, let's start the ball rolling. I'll now hand it over to Cheow to give the opening remark. Cheow, please.
Yeah, hi. Good evening, everyone. Thanks for spending your time with us. We are glad to really collaborate with Data Science SG. I think our first collaboration with them to really, reach out to the community at large, the data science community at large. The thing is that, GovTech has gone through a tremendous journey for the last about 6 years or so in terms of dramatically changing the landscape of how government uses technology as we move forward. And one of the most important things we did over the last 5 years was really to rebuild the engineering capabilities within government, so that today you'll find that we have more than 750 engineers, computer scientists, data engineers, etc., who are working together with us to really use technology for public good. And during this time of COVID, it's even more pertinent. About 3 months ago, we were all tossed into really the virtual unknown, right? Whereby everybody was coming to us to ask us to use technology to help solve many of the issues during this unprecedented crisis that we have. One of the scariest things is that none of us know what it was, what's the right solution. We were literally tossed into the unknown. It was a scary thing for actually all of us. But the beauty of it is that unlike the past, we were able to activate a whole bunch of very, very bright people to come together to solve very difficult problems, whether it's in contact tracing, whether it's in dealing with, for example, the fusion of data from multiple sources to come out with the ability to map networks of infection, etc., etc. It was a tremendous opportunity for all of us. And I mean, credit to the team. The team has been literally working 7 days a week to get all these things done. And we could not have done this without the strong capabilities that we've built over the last 6 years. If we had to call a tender and always go out there and so-called approach vendors to do these things, I think everything we have done will slow down significantly. Because fortunately or unfortunately, the turnaround time for this crisis is always few days, 1 week at most. Nobody's going to wait for you for 1 month to do something. So, credit to our engineers. And I think today, Bertrand will talk a little bit about Vika. But even a chatbot became very useful for us during this crisis, whereby we used it significantly to offload a lot of the so-called the manual labor that's needed to answer significant amount of questions about COVID, about health issues, etc., etc. And then Delon will talk about VigilantGantry, whereby this solution kept evolving. First, it was about temperature taking, and then it went a lot further than that. So I just like to say one last thing, which is that the community is important to us. In fact, they've been reaching out to the community nonstop. And we are very touched by the fact that during this whole period, we had almost 600 volunteers who came forward to try to help us. And I think this is what the crisis brings. It brings people together. It brings like-minded people who truly want to help together. And we're also reaching out to the community to help the community out, because the reality is that this has been quite a difficult time for many people, where people have lost their jobs. Really, really good people who are in a transition right now because their startups is kind of slowed down quite a fair bit. And about 3 weeks or 4 weeks ago, I was in a similar webinar whereby we openly went out there and said that we are more than happy to hire at least 300 to 400 people in this whole process to help us deal with the crisis, and tide people over for this very difficult period. So the community is important to us, and we keep reaching out to the community. And I think this is, again, one of the many other webinars that we'll be doing. So with that in mind, I'd like to thank every one of you for attending. And let me just hand over the mic to the presenters. Thank you.
Hello, everyone. I'm Bertrand. I'm from the GovTech Moments of Life virtual assistant team. And then I'll be talking to you about the virtual intelligent citizen assistant that is being developed by our team. Next slide, please. Okay, so the virtual intelligent citizen assistant, or VICA for short, is GovTech's next generation chatbot platform. It's a multi-tenant platform that is currently under development. We are targeting the initial release by the end of this year. And our team is currently growing. So if you're interested to help us out, to get in touch with our HR team. So in addition to the chatbot platform functionality, VICA will eventually also support call center AI features too. So for example, if a citizen calls into an agency call center and talks to a live agent and for help on any particular topic, we want to leverage AI technologies to enrich and enhance the interaction for both the live agent as well as for the citizen. So you can see this in our product vision, where we want to basically leverage AI to enhance the experience for all interactions with the government, or conversational interactions with the government. And this will be an omni-channel platform. So in addition to the text channels like a web chat and WhatsApp and Telegram and Facebook Messenger, we'll also be supporting voice channels in the long term. Next slide, please. So I thought that before I jump into VICA, it might be helpful to cover some of the basic concepts and terminologies that are used in the chatbot industry, and also some of the performance metrics and the overall development process that pertains to chatbots. So the natural language processing, or NLP, refers to the ability of the chatbot to understand and generate natural human language. So that's where NLU for the understanding part and NLG for the generation part also comes from. User utterance refers to the phrase or question that the end user issues to the chatbot. The intent refers to the intention of the user utterance, which the chatbot would then classify based on its training data. The variation refers to an example user utterance expressing a certain intent. This is also known as a training phrase. So typically when you train a chatbot, let's say the chatbot contains 1,000 intents. Each intent may contain anywhere from between 10 to 100 or more variations or training phrases. An entity in the chatbot world refers to a variable parameter in the user's utterance that belongs to a particular class, for example, a country, date, or a name of an agency. Okay, next slide, please. So named entity recognition, or NER, refers to the ability of the chatbot to extract these entity values from the user's utterance. So for example, if the user asked the chatbot, what is the weather forecast for Singapore this Sunday? The chatbot's NER feature will be able to pick out that Singapore refers to the city the user is asking the forecast for, and Sunday as the date the user is asking the forecast for. Slot filling prompts refers to the chatbots prompting the user for entities that are not yet specified. So for example, if the user said, what is the weather forecast for Singapore? The chatbot may then issue a slot filling prompt to the user to say, what day would you like the weather forecast for? Right. Fulfillment refers to the chatbot-specific business logic code that needs to be implemented to fulfill more complex intents and transactions that require database and API reads and writes. And then lastly, the annotations and training refers to the ongoing process even after a chatbot is released, where real-world user utterances are reclassified as needed and tagged with entities by human annotators to improve the NLU accuracy. Okay, next slide, please. So what are some of the common performance metrics associated with chatbots? So the most easy to understand one is the accuracy score. So this is basically the metric to measure the NLU performance, or how well the chatbot is classifying the user's utterances into the correct intent. So the metric for this is, out of all the predictions or classifications, what proportion was correct? So that's really quite straightforward. Now, we also have the F1 score, which would be quite familiar, I think, to the data scientists among you. It's also a way to measure NLU performance and accuracy, and it's actually better than the accuracy score itself. The formula that is used is basically the harmonic mean, the precision, and recall metrics. So the precision metric is basically based on the true positives and false positives, and then the recall metric is based on the true positives and false negatives. So the advantage of the F1 score over the accuracy score is that it takes the skew between the false positives and false negative predictions into account. Another common metric, the containment or deflection rate, which is the one that the upper management typically cares the most about, because it measures the cost savings, is what percentage of customer interactions were contained or handled by the chatbot without having to be escalated to a human support agent. So this will, if the containment rate is very high, it means that it's saving a lot in terms of human support cost. Right. And then lastly, we have the user satisfaction metric. So this can be measured by a user clicking on thumbs up or thumbs down, or giving a 1 to 5 star rating after the interaction with the chatbot, to indicate how happy they are with the chatbot support. Okay, next slide, please. Okay, so what does the typical chatbot development cycle look like? So the first stage is the define and build phase. This is where you're gathering the market and the customer requirements, defining the use cases, the intents, entities, and the conversation dialogues that are needed for the chatbot. The next phase is then the training stage, where you develop all the variations and training phrases for all the intents that you have defined in the define and build stage. Then after that, you have the enable stage, where you're adding channels to allow user interaction. So that could be a web chat UI, that could be WhatsApp, that could even be a voice front end if that's a scenario that you want to support. After you've done that, then you would basically test the performance of the chatbot and measure its NLP performance in terms of the accuracy and F1 scores, to see whether it's performing to a level that is suitable to actually publish a chatbot. Now, if it's not, then you will basically loop back into the define and build stage again, and then cycle through until you get to the point where the chatbot is performing up to your standards for release. Once that is achieved, then you would then publish the chatbot to the end user, to your user base. And that's not actually the end of the process, because you also have the analyze phase after that, where you're actually monitoring all the real world end user utterances and performing analytics on it in order to improve the quality of the data, to improve the F1 score and accuracy, as well as to improve the breadth of the topic coverage of that chatbot. So the key takeaway here is that it's an ongoing cycle. You're never fully done. You're always working on improving the chatbot, even after you release it to your end users. Okay, next slide, please. So just going over a brief history of chatbots. So I think the whole concept of a conversational AI started 70 years ago in 1950, where Alan Turing, one of the fathers of computer science, proposed the Turing test, which I'm sure many of you have heard of before. But in really briefly, what the Turing test is about is if a user is conversing through a text channel, like writing a paper letter, or even like texting with an unknown entity. And through that conversation, the tester is convinced that the unknown entity is a human being. Then the unknown entity is said to have passed the Turing test. And this unknown entity could be a conversational AI. right? So that's what the Turing test is about. So one of the first chatbots was created in 1966, ELIZA, which was created at MIT. It had a persona of a virtual psychotherapist, and it used keyword and pattern matching for its NLU. Another chatbot was created in 1972, Perry, at Stanford, and this had a persona of a virtual patient with paranoid schizophrenia. So the interesting thing is that this Perry chatbot was then linked up with the ELIZA chatbot, so they both had a conversation with each other. So you had a virtual psychotherapist counseling a virtual patient. Yeah. Next slide, please. Okay, so then moving forward, so in the 2000s, we saw the advent of early commercial chatbots and conversational AI. And these use more basic NLU models like pattern matching and logistic regression and maximum entropy models. In 2011, there was a bit of a landmark where IBM Watson won the Jeopardy game show against the top human contestants. So this in the domain that involved NLU, this was a significant milestone where computers were able to outperform the world's top human beings, right? And then in the past decade, from 2010 to now, we see the advent of modern chatbots and conversation AI, like Siri, Alexa, Google Assistant, and Microsoft Cortana, which I'm sure you're all familiar with in terms of daily usage. They use advanced machine learning models like neural networks and deep learning. And they have leveraged over the past 5 years, they've leveraged all the recent advances in cloud computing, big data, and GPUs to speed up the training and performance of the machine learning and deep learning models. But even with all these recent advances, there is no AI, conversation AI, that has comprehensively passed the Turing test yet. So this remains a challenge for chatbots and conversation AI in general, is when will a chatbot ever comprehensively pass the Turing test. Okay, next slide, please. So where are we today with GovTech? So basically, we have 60 plus Ask Jamie agency chatbots, both on the internet and intranet, and they're using a Singapore-based chatbot platform and NLP engine provider. Next slide, please. In terms of where the industry is today, over the past 5 years, due to all the technological advances, there's been a proliferation of chatbot platforms and NLP engines. For example, Google Dialogflow, Microsoft Louise, IBM Watson, Amazon Lex, and Rasa, which is an open source chatbot platform. They all leverage deep learning models, and they do support advanced conversational authoring, such as contextual understanding, named entity recognition, or NER, and slot filling. Next slide, please. So what is next for GovTech specifically? So this is where Vika comes in. So you can see on the left side where we are today, we are using the Ask Jamie platform, as we were talking about. Now, as we move forward into Vika, you can see that the architecture is much more sophisticated, and we'll be offering many more features as compared to what we do today. So just to explain some of them, starting from the bottom up, the data layer, you see that there is the unified data layer component. So you can think of this as a whole of government a database that is storing all the chatbot content for all the 60 plus agency chatbots that will eventually be hosted on Vika. We also have the advanced analytics feature, which I'll show you some screenshots of later on. So these are basically tools that will operate on the unified data layer and will allow the agencies to improve the quality of the chatbot content, to improve the accuracy as well as the topic coverage. On the bottom right, you have the data transform engine. So this also interacts with the unified data layer to allow the automated migration of chatbot content between different NLP engines. So moving up to the next layer, the custom processing layer, on the left, you see the whole of government business logic. So this includes all the pre-built integrations that we'll be developing, for example, for user authentication with SingPass and CorpPass, for user payments, integrations with payment gateways like Stripe and eNets. On the right, you have the agency's business logic. So these are all the chatbot-specific fulfillment code that need to be developed for each agency chatbot. Then moving up to the next layer, the natural language generation, one of the key features of Figure is that we are going to be NLP engine agnostic to a certain degree, which means that we'll be able to support multiple NLP engines. So this has two key benefits. One is that we'll be able to allow agencies to pick and choose to a certain degree the NLP engine that best fits their needs. And it will also allow us to future-proof our chatbot platform. So, for example, if in a few years' time there is some, cutting-edge NLP engine that comes out that blows the competitors out of the water, we would be able to integrate it into this Figure platform. Okay, so then moving on to the next layer, the channel integration layer on the top, we'll have a common branding by implementing a unified front end, a unified web chat UI that all the different agency chatbots can leverage. We'll also be planning to build a super bot. So the super bot, you can think of it as a whole of government e-concierge. So one of the problems we have today is basically that there are over 60 agency chatbots, and for the average citizen, they're not always sure which chatbot to go to ask the question or to get the issue addressed. And the idea behind the superbot is that we'll build this one chatbot that everyone can go to for all of the government interactions, right? And this superbot will be smart enough to be able to triage the user's query or utterance to the appropriate agency-specific chatbot for follow-up behind the scenes. Right. So, for example, if the user says, "Oh, I want to pay for my speeding ticket," right, then the superbot is smart enough to know, okay, speeding ticket means this is a question for the Singapore Police Force chatbot, and it will forward it to the Singapore Police Force chatbot behind the scenes. Right. So, whole of government customization, that refers to all the pre-built chatbot data that we'll be building that the agencies can leverage to speed up the chatbot development process. For example, we'll be creating a database of Singapore street name entities that agency chatbots can leverage if they need to support Singapore street names in the chatbot conversations. And then last but not least, on the top right, we have the Singapore localization. So this is basically the ability to be able to support Singlish expressions like la and law in our chatbot, since we are Singapore after all. Okay, next slide, please. Okay, so I think I've covered quite a few of the Figure benefits in the previous diagram already. So I think we can move on to the next slide. And then this one also, I've gone over most of these in the diagram already, so I think we can also jump over to the next slide. So talking briefly about the tech stack we are using, it's actually very similar, quite similar to web development. So on the chatbot development side, we are using the MERN stack, so MongoDB, Express, React, and Node. For the front end, for the web chat client, and as well as the content management UI we are building, we are using React.js. And then on the back end, for the chatbot fulfillments, we are using Node.js. Now, on the advanced analytics tools development end, on the front end, for the analytics UI, we are using React.js. And then on the back end, for our machine learning model pipeline, we are using Python. Yep, next slide, please. Okay, so really briefly, for the advanced analytics tools that we are building, we are now already supporting two key features. The first feature is intent conflict detection. So this basically identifies the direct and semantic conflicts between training phrases of different intents. So basically, when you train a chatbot, you don't want the training phrases for two different intents to be too similar, either in terms of being an exact match or having, being similar in terms of meaning, because that will actually confuse the NLP engine when it does the intent classification. Right, so this tool helps to identify those overlapping training phrases. So it improves the chatbot accuracy and leverages unsupervised learning and clustering machine learning models. The other feature is the knowledge gap analysis feature, which identifies missing and in-demand topics based on the real-world user utterances, and this basically improves the topic coverage of the chatbot, and also uses unsupervised learning and clustering models. Okay, next slide, please. In terms of what is next for advanced analytics tools, this is currently under research, and I think this is one of the really interesting areas because we are only, limited by our imagination and creativity in thinking up features to support in these tools. So one of the examples of something we are planning to support in the future is calculating an intent diversity score for each intent, where 0 means that all the intents are completely the same, and 1 means that the intents are very diverse, which is actually the goal that we want to achieve. For example, on the column on the right, the don't column, you can see the training phrases for the intent are very, very similar, which is actually not ideal. And on the left, you can see the training phrases for the given intent are very diverse, which is the what we want to get to. So this feature will help us to get there. Okay, so next slide. In terms of what we've developed so far with the advanced analytics tool, this just gives you an example. As you can see, this shows that all the training phrases that are exactly the same between different intents, which should never be the case, right? So this tool is helping to flag those out, so the agency users can go in and clean up the chatbot data to remove all these training phrases that are exactly the same, even though they are grouped under different intents. So if you go on to the next slide, this also shows similar views, but not just for exact matching training phrases, but for semantically similar training phrases used across different intents. And then move on to the next one. So this view just shows the same thing, semantically similar training phrases, but we show it as a cluster rather than just pairwise. And then if you move on to the next slide, our knowledge gap view actually shows all the real-world user utterances that are not currently trained in the chatbot, but are very popular in terms of being asked by the end user. So this is basically a hint to the agencies to basically add in new intents to cover these new topics. Yeah, and then I think if we move on to the next one, that's pretty much my presentation. So I think we can open it up to questions at this point in time. Okay. So will the chat content be saved? I'll just take the questions one by one. Will the chat content be saved for auditing purpose? Will the chat content be saved for retraining purpose? Are all of these data anonymization treatments for these conversations containing sensitive PII data like NRIC, mobile, name, email, and so on? Yeah, so I think that's a great question. We do plan to save the chatbot content, where it actually makes sense for where it will actually benefit the chatbot data in terms of being able to derive useful insights and analytics that will help to improve the quality of the chatbot data. Now, that being said, we do plan to fully respect, user privacy and observe, like the PDPA, the Personal Digital Privacy Act, and therefore we do not intend to store any, PII, personally identifiable data in our chatbot platform. So it's going to have to be a balance of the two, but yeah. And the other thing to note is actually the vast majority of our chatbot interactions are not tied to any user identity. For example, if you go to the MOH website or the MOE website, you can ask it questions without having to, sign in with your SingPass or provide your NRIC details. So most of it is actually anonymous in the first place, right? Okay, so another question is, well, there are quite a few. Let me say, yeah. So another question is it possible to know if we use any framework for chatbot developments? So the framework for chatbot development that we use, so some of the common chatbot frameworks out there today, what we are referring to as the NLP engines. So for example, like Google Dialogflow, Amazon Lex, Microsoft Louise, these are all basically chatbot frameworks that can be used for development. For the purposes of this, presentation, I think it's probably better that we just kind of keep this discussion general around that area. In terms of the development languages that we're using for the chatbot, the Vika chatbot platform, is basically the MERN stack that I had mentioned earlier. So basically JavaScript, TypeScript, and using the Node.js and React.js frameworks, right? So another question is, will the reusable parts of Vika be open sourced? So I think that that is still something that is to be determined. So we haven't made any active plans to open source Vika to the general public at this point, but I think that we want to remain open-minded to that possibility. So if it does make sense for and whatever reasons in the future, that's certainly something that we can consider. Another question, many potential prospects want chatbots or self-service applications. However, many do not have much budget. Is there a budget amount below which you would not take on a project? So one thing to clarify about the Vika platform is that we are not actually designing this as a platform for the general public to build chatbots on. So there are commercial products, like I mentioned earlier, Google Dialogflow and Microsoft Louise, that provide such functionality, right? So our chatbot platform is very much catered to our customers, which are the government agencies, the 60+ government agencies that we intend to eventually support on this platform. So I think that I've run out of time for questions, so I think I'll hand this back to the presenters at this point.
Okay, thank you, Bertrand. I think now we have Delon to share with us the VigilantGantry. So Delon.
Hi guys. Firstly, I'd like to thank the organizer, the DataScience SG team, and the GovTech TechX organization team for hosting us. So we appreciate your hard work in organizing this event. We know that it's really difficult, especially in this trying time. So again, I'm privileged to be part of this panel of distinguished speakers. So hello, Cheow, hello, Bertrand. My name is Leonard. I'm from the Video Analytics Department, Data Science and Artificial Intelligence Division of GovTech. So I will take the next 15 minutes to share with you on our project VigilantGantry. Next slide, please. So as you may understand from the invite description, VigilantGantry is an automated temperature screening gantry that augments existing thermal systems to enhance the rate of contactless scanning. Wow. So I guess what you want to know more, right, from this sharing session, right, what are the things precisely that we did, right, to make a VigilantGantry happen? So you might ask, are we building the whole gantry by ourselves with a team of 2 or 3 engineers? So, or is VigilantGantry only a software while the others are just provided by vendor, or is it a mixture of software and hardware? So we shall see. So next slide, please. So here's the agenda for this sharing. So I'll start with the problem statement. Design, prototyping, field testing, industry adoption, and collaboration. Next slide, please. So what we observed after the announcement on DORSCON Orange and before the circuit breaker period. So we saw queues everywhere during the peak commuting period, especially in commercial buildings. So according to Straits Times, people are waiting as long as 40 minutes outside the hot sun. Next slide, please. So my team and I were very curious of this issue, so we decided to delve deeper. So we visited a dozen of commercial buildings and tried to understand the reason for the queue. Specifically, we are looking at bottlenecks, especially in the operation. So this is what we have discovered. So I'll orientate you guys on the illustration of this slide. Okay, so this is a floor plan of a typical building lobby and the manpower deployment by building owners. This is after the announcement of DORSCON Orange and before the circuit breaker period. So the one bounded in the red dot are the additional manpower required for thermal temperature screening operation. So as you know, DORSCON Orange is compulsory to take temperature, right, before you enter the building. So these are the additional manpower that is required. So on your left, you can see the doors and the floor marking directing the visitor to the gantry. So you will be greeted by a security officer who will direct the visitors to the gantry to enter the building. So there's a you can see the door and the gantry. So there's this distance. So the job of the ground staff at the door, right, the one that nearest to the door, is to do crowd control and also remind visitors to remove their headdress and sunglasses, so that a visitor can be screened properly by the thermal camera. So one thing that shortfall of this thermal camera, right, is even though so it's there. So if you are covered, right, they are unable to really penetrate through the cloth to detect your skin temperature. So that's one of the shortfall of this thermal camera operation. So in other words, you actually can game the system by covering yourself. Hence, from our understanding from the building owners, it's important to have this ground staff at the door to remind the visitor to remove their headdress or sunglasses. Even though there's a warning signs on display, people tend to forget. So visitor walk past the reception. Another ground staff, right, is actually deployed at the thermal camera to monitor for febrile visitors. So from our discussion with the building owners, we understand that the ground staff, right, they actually have to look at the thermal camera for up to 6 hours a shift in some instances. So imagine you are just looking at thermal image. So that will be actually quite a difficult job. So if a thermal camera indicates a potential case of fever, the ground staff will have to attend to the suspected visitor and take a secondary temperature using a thermal gun and deny entry to the person. So imagine, right, this ground staff, right, is attending to one person, right? So a febrile visitor, right, might slip past the cracks because the ground staff can't be multitasking so much. So it's actually impossible, what we feel, right, to monitor the thermal screen and do crowd control concurrently. So in short, for each lane of the entry, we're looking at the minimum deployment of having 4. So can you go to the previous slide? Yeah. So you can see the illustration. In short, each lane, right, of the entry, we're looking at a minimum of 4 ground staff being deployed. Hence, this is the issue. So next slide, please. So actually, to recap, right, we have 2 problems that we want to address. Firstly, long queue due to the long waiting time and manpower crunch for the building owners. So believe that this issue will actually resurface as we are going to phase 2, because everybody is going probably, we are seeing more and more people going back to work. You will definitely have to have thermal operation. So these are some of the issues that we will see next time. So next slide, please. So what can we do? So we look at the floor plan data again. So what my team and I actually discussed, right, is what do we have? So we realized that we do have a thermal camera system, we do have a gantry, and we do have a CCTV overlooking the gantry. So imagine this scenario: a thermal camera, right, may sense a febrile person, then the gantry will open. Or another scenario, a person covering himself, but the thermal camera is smart enough to inform the gantry that, oh, he's covering himself, so the temperature taker is not accurate. So don't open, and also give out a visual and audio alert to remind the person to remove his headdress or sunglasses. So that's the basic of VigilantGantry. Next slide, please. So the basic idea of VigilantGantry is to make existing thermal camera, the existing CCTV camera, and the existing gantry communicate with each other. Next slide. So you can think of it like a sort of like a smart home hub that you find in most places that sell. You have a sensors, you have I/O. So the hub must be intelligent enough to actually automate I/O operation for the benefit of the user using intelligent sensors. Next slide. So what will impact if we have this intelligent gantry system? So as illustrated as this diagram, the febrile visitor or visitor covering their faces with headdress and sunglasses will not be granted access by the VigilantGantry. So rejected visitor will naturally approach the reception, and manual temperature screening can be made for further verification. So in short, right, we think that the impact is the ground staff can potentially take on supervisory and important tasks such as attending to emergencies and answering queries from visitors. And for visitor point of view, right, there's actually no change in their daily activity as per their daily routine. So hence, we actually, this is the whole idea. We want to automate this as much as possible. Next slide, please. So now that we are very clear about the problem statement, we are able to come up with a set of design principles for our solution. So they are actually utilizing existing hardware, minimizing disruption to existing processes, adaptability, accuracy, and performance. Next slide, please. So we come up with a VigilantGantry. So this is the system architecture diagram. So let me orientate you guys on the diagram. So on the left are the sensors. So they consist of off-the-shelf optical camera that you can buy anywhere online, and imagery from thermal camera. So these are existing thermal camera. Building owners really invested a huge amount of money in that, so we will not actually change. So we just take input from the thermal camera. So in the middle is where the VigilantGantry software lies, running off a GPU laptop. So on the right are the outputs, the display and the gantry. So we are able to control the gantry using this software. So back to the middle part of the diagram, which is the VigilantGantry software. So VigilantGantry actually consists of 5 modules, all of which are Dockerized, of course. So we use a Docker compose to make them talk to each other. So you can think of it like all of them are like microservices that you actually can talk to each other. via HTTP post request, for example. So the main reason why we split it to 5 modules, right, is actually for modularity, because what we know that every building may have a different component. For example, a CCTV has a different, maybe the protocol is not RTSP, maybe the protocol is WebRTC, maybe the thermal camera is another type. So we make it very modular so that it actually can plug and play. So that's the whole concept that we are splitting into the 5 modules. And another reason is actually for work distribution wise with my teammates, it's actually much easier when you modularize. So this is pretty straightforward. Input from the IP camera via RTSP goes to the face segmentation module. The face segmentation module uses a couple of deep learning models to quantify the amount of exposed skin of a detector face. So in other words, as I explained the problem just now, right, if a person is covering his eye, he's covering his face, right, our algorithm is able to pick up that you are covering. So hold on, we are unable to set accurate temperature. Hence, this is what our algo was designed to do. So on the other hand, the thermal image go through the color segmentation module, which we developed, and this uses a traditional computer vision to look out for big red patches, which are signs of high skin temperature. So the middleware will do 3 main tasks. Namely, decide whether to open a gantry based on the threshold that we define, push information to the display for the ground staff to monitor, and push information to a database for logging purposes. Next slide, please. So going to the details of each module, probably I think this is something more the technical part. I believe the audience will be more interested in this section. So for the color segmentation, we actually use this HSV, so hue saturation value color model. So from there, you're able to pick out a very distinct color. For example, fever is usually red color, right? The thermal camera will show a red color patch. So we are able to detect firstly the red, and we realized from talking to the vendors, the size of the patch does matter. So sometimes you do have a little red spot on your forehead. Doesn't mean you have fever, but if your whole face mostly covered with a red patch, this is a sign of high skin temperature. Hence, we use a blob estimation, a traditional computer vision to estimate the size. So we use the size of the red patch as one of the threshold to determine if the person is having a high fever. Yep. So actually, throughout this whole process, we actually talk a lot to the vendor, actually the thermal camera vendor, to make sure that we are able to calibrate our color segmentation module accurately. Something we are very grateful that the vendor has been very generous with his time. We are able to come up with quite a good model to detect all these fever cases. So implementation wise, we did everything in Python because it was fast, and the prototype, it was fast to prototype and iterate the features very fast. Because we are actually doing it quite fast. I think this whole project, the development time is about less than a week. So actually, if we do it in Python, right? So every changes that we do, we are able to push quite fast because we use Python. Next slide, please. So for this face segmentation module, we use 3 deep learning models. So firstly, a person detection model. So we use at that time YOLO V3. So I understand that recently actually there are quite a couple of at least 3 additional person detection model has been surfacing. I think Facebook released a detection with a transformer. Then there's a YOLO V4 and V5. So we actually tried it. So at that time we actually used a V3. So probably later we can discuss more about the other detection that we are using in the chat. So we do need a person detection model, right, to ensure that we are performing the right, when we do the segmentation, right, we have to make sure we are performing on the right person, because you got so many person, right, maybe the background, you don't the algo to detect that person, right. So we want to detect people who are actually walking towards the gantry and not the background person, which is far away from the gantry. So hence, we are able to estimate this red dot. If you see this image, this lady here, there's a red dot. So this is estimated. This is the person's centroid coordinate. The white box is actually the intercept zone. So once the red comes in contact, intersect with the white color box, then the person face detector will be triggered. Face segmentation also will be detected. So to compute the face exposure area percentage, we needed to calculate the total face area using a face detector and expose face skin area using a segmentation model trained for faces. So to go to the specific, for the face detection model, we use this, there's this very good, very lightweight one called ultra light fast generic face detector 1 MB. So the size of this model is like 1 MB, and it's able to run in the CPU for very, very efficiently. It's pretty fast. And for face segmentation, which look at your exposed skin, right? We use a UNet, which is quite typical in a lot of these segmentation tasks. Next slide, please. So I took a video from this GovTech YouTube channel. So this actually explains how this VigilantGantry works. So if you can see that the face segmentation will be triggered when the person's centroid coordinates, right, is within a predefined ROI, the region of interest. So the face segmentation model will be triggered at an estimation of the exposed skin, right, can be estimated. So in terms of implementation detail, we did it in PyTorch because that's basically our favorite deep learning framework for training and inference. So we actually retrained the model and using a couple of data augmentation. So reason being is actually what we are taking the field of view of these images are actually a CCTV. So as you know, CCTV usually is wide angle, then it will be distorted. So we did quite a bit of data augmentation to increase the robustness of detection for the person, for the face, as well as the segmentation. Next slide, please. So there's this middleware. So think of it, middleware is like a coordinator. So middleware simply takes the input, it performs the business logic and outputs the result. So we use Flask and the request packages for this routing. Because again, that's something that we are the most familiar with. So currently, to improve the performance, we're actually looking at this fast API, asynchronous operation. So we thought that this really can benefit. Because actually this whole VigilantGantry is very important for it to be performance, to be running in real time. Because you don't want to be at a gantry for like maybe 5 seconds. So we are actually looking at all these details to make sure that it's performant. So for the Bluetooth module below, actually we work with the industry, with our vendors to modify actually the communication protocol. So the industry standard, right, is usually hot wired or using vegan protocol. So to simplify things, at least for this prototype that we have to develop quickly, right, we choose Bluetooth because Bluetooth is actually very easy to integrate. Our laptop has Bluetooth communication. So another reason for having this Bluetooth is actually give us flexibility. So when we started with VigilantGantry, we thought that it might not be a gantry, it might be a door, it might be a smart lock. So if having a Bluetooth, we thought it will be wide enough to cover all these devices. So again, I think our industry partners have been really accommodating to our requests and are willing to experiment with us on some of these questions and various technical discussions that we had. Next slide. So putting things together, so we started to prototype in our office before we integrate VigilantGantry with our vendor. So you can see that we quickly built a segmentation model, trying to cover our face, the picture on your left, as well as we go to a vendor to really test. So vendor was super nice, hosted us, actually made a lot of like accommodation in terms of the technicality, and we were very grateful with their help. So next slide. So I thought, right, it's important to emphasize the success of VigilantGantry, right, lies not just with GovTech, but also the industry partner and also our agency partners. So who trusted us and willing to give us the opportunity to deploy VigilantGantry in the real world for testing. So this is something very new and very untested actually. So next slide. So we have the prototype, we have a support from the industry. Now we need to have a place to deploy it. So we did a trial in NUS library for 2 weeks. So here are some of the key outcomes. So there are actually more than 1,000 visitors that use VigilantGantry daily for these 2 weeks. So about 87% of the visitors were satisfied with the experience. So the throughput, right, that something that we really want to measure, right, how fast the gantry opens, right, is about 30% per minute. So the waiting time is about 2 seconds per person, which is pretty fast. So the conclusion was VigilantGantry was able to effectively conduct a fever screening for a large number of people without increasing the manpower. Next slide. This is the NUS trial, some images, some photos. So these are the real trial. So they are actually using it for a real there's the real use for it. So next slide. So these are the equipment that we use. So if you can see, right, the equipment are literally off the shelf. So it's not like a industry something we have to customize. So actually we took pieces together, string it together, and we are able to make a prototype of it. Next slide. Yeah. So of course we did a lot of testing. We have to actually keep going through this gantry to really make sure that the whole system is performant as well as accurate. So next slide. Yeah, so these are some more examples. What if you simulated a fever case, putting a heat pad on the face and the neck. So actually we use that to make sure that everything is robust. So hence, this is how we convince our stakeholder that, okay, this system works. This is a very good idea. Please deploy. Next slide. Yeah, so further trials. So you can see actually the throughput is pretty fast. So in terms of accuracy model, we need some calculation. So within 2 seconds, the ability of it able to detect whether a person is covered or not is actually at a high 90%, something that we are quite proud of. So the FR score was very satisfying. Next slide. Okay, so here are key learning points. So VigilantGantry performed well in terms of the throughput as well as the face segmentation and the color segmentation accuracy. So we designed it to be agnostic to different fever screening system, which is true because after the NUS trial, we did deploy in a couple of places, all of which have different screening systems. They all work. So thanks to being able to really make it modular. So we also have some feedback that VigilantGantry actually can be expanded to allow for face indexing, logging of body temperature, as well as dispense of temperature check stickers. So next slide. So we have open sourced our deep learning model, the face segmentation, the person detection, and so a combination of these. So we call it the VigilantGantry engine. So we also conducted several workshops with the industry. Purpose is actually, we know that we can't scale up alone. So actually trying to encourage the industry to take up this idea, we'll help you technically in terms of the technical aspects. Hopefully actually you can deploy to more places. Yeah. So we actually also deploying in other places. There are several upcoming deployment too. Yep, so that's the end. Next slide is the end of my slide. So I'll take a couple of questions. So KH mentioned, you mentioned that VigilantGantry was released in a week. How many people worked on the release? Okay, so we finished the prototype in a week. But to be honest, the real development is actually when you do the trial, because in the lab setting, actually there's a lot of cases that you can't be tested. So a lot of changes, right, they have to be made on the spot where we do the trial in NUS. So that's a great learning experience, putting something, the prototype, straight to the real world, and you really fix the bugs there. So how many people work on that? So we have another engineer with me, Bill. So both of us we did it. Okay, so let me find, okay, so Jack New. So as cameras and video analytics becoming ever prominent in Singapore, technology other than thermal estimation such as facial recognition, behavior recognition, crowd control recognition, crime recognition is not technically difficult to integrate. Keep jumping. To be integrated as a module in a camera, such as surveillance can be prioritized over privacy. Is there any practices to prevent us misuse of integration of technology in computer vision? Yeah, actually we do agree with you that privacy is really important. So at least for our prototype, our deployment, right? Actually, we don't take any images. We do not take any. We do not store any data. So because we don't need to store data, we just perform the check. If it pass, it pass. Then it will go through. So so doesn't we do not do that. So Kai Wei Chen. So how much data do you need to collect before the augmentation, before the model works? Is it required for all 3 models? That's a great question. So of course, we started with of the what is publicly available, because we ourselves can't collect so much data. So actually, the whole technique is really data augmentation. So if you read the recent paper on maybe YOLO V4, right, actually the magic is really at the data augmentation. I read about this mosaic data augmentation, which actually make the model really good. So actually, you might be surprised that there's readily available images like your Coco are actually quite efficient. You just have to do a bit of data augmentation, right? And it actually worked quite well without actually much tweaking to the model. So our idea is always the data augmentation seems to be like one of the most powerful tool that most effective way, right, to really improve your model. So there's another question by Darren Sin. For NUS field testing, were there actually people with fever that the camera detected? If not, was it a good test? And good test for people to test. So you're right. Actually, so even during that time, actually NUS said that no, we shouldn't. A student with fever should not have been should be going to school. So we do not find any fever for these people. So what we did is actually we simulate. We have our own colleague, right? Put heat pack on themselves. Then that's how we do the simulation. So yeah. So actually the whole thing about this NUS is, in addition to the accuracy test, we also want to look at the speed and how people perceive this technology. Whether is it very intrusive, people have to wait 2 seconds. Is it really troublesome to wait for 2 seconds? So these are some of the understanding that we probably want. Yeah. So
okay. Let's maybe revisit some of the other questions. Maybe
sure.
Let's look at the trend. I just saw one question. Okay, never mind. Maybe Delon can take this up first. Which government agency is responsible for commercializing innovations such as VigilantGantry developed by GovTech? Oh, I think this one maybe Cheow may be a better person.
Yeah. There isn't. I mean, we don't really commercialize it like. Okay, GovTech actually is a center agency for all technology, innovation, etc. So what we do is that we take a very product approach, whereby when we see that something, we do a lot of white space stuff. Actually, among our teams, we've got so many white space projects going. When something has potential, we normally try to start doing our selling. In a sense, we sell to our agencies to see whether there's a very use cases that can be used to make it happen. And once it's happened, we start implementing. And once we implement, we will start scaling up. If we find that we are able to go beyond just 1 or 2 agencies, and hopefully we'll hit like tens of agencies, or even sometimes the whole government, right? Now, do we commercialize it beyond government? Most of the time, answer we know, because we are a government organization. But how we commercialize it is actually we kind of open source the codes, or open source some of the technology that we built, so that other commercial entities can take it and go beyond the government. So that's how we do it. But because, frankly speaking, we don't make money. That's not our job. Our job is to come up with solutions that can solve interesting use cases across the government as we move forward.
Okay.
Thank you.
Thank you, Cheow. Let's take one maybe for Bertrand. I saw something that's quite interesting. Because the question keeps on skipping around. Give me a second.
Yeah, I've been typing out answers to some of the questions already. So
okay, Ken. Yeah. Thanks. Maybe then I'll take one. I'll ask one to point one to Delon then. So Delon, one of them was saying. So Jackson actually mentioned like one potential turbocharger for your project, right, is to marry it with 5G and edge computing. What are your views? Have you all thought about that, and are you all experimenting with that as well?
Yes, you're right. Yeah, actually, one of the capability that my team and I is actually want to build, right, is actually edge computing. So currently I'm running off the laptop, which is not ideal because I mean deployment. How can you make a laptop? So yes, you're actually very right that edge computing is something that we are looking at. 5G definitely yes, but for the purpose of real time, it's basically running on the edge. That's the whole value of edge computing. Yes, so I thought that's a great question. Something that personally I'm working on in GovTech on edge computing. So hopefully we can see the light of day. Some of the other products that we develop using edge computing.
Okay, Ken. I trying to look for question for that is for Bertrand, but I think Bertrand very efficient in answering the question.
I was just spending Leonard's presentation answering all the questions, so I think I've answered most of them already.
Okay, I think that's all the time we have ready for today. So I'd like to again thank Cheow, Bertrand and Delon for sharing the great work that is done by GovTech. So with that being said, I think a round of applause for those who are still around, please, for them. If you can clap, we won't be able to hear your clap, but I think they will appreciate the clap. Okay, so thank you, Yo. Thanks for the clap. Okay, so with that being said, let me hand it over now to Karen to sort of do a wrap up. Karen.
Okay, thank you, Ku. Just a quick one, if you can go to the slide. Okay, so this is Karen from the GovTech StackX DevRel team. Big thank you again to the DataScience SG group for supporting us in this meetup, and the GovTech team behind it organizing. So organize a series of meetups. One of them, a few of them is deep dive sessions on cloud machine learning, where we invite government and private sector speakers. So the next upcoming one is on Thursday, 25th June. So please sign up on our StackX meetup page to learn more about our meetups. So next page. Okay. So we'd like to invite you to join us at our developer portal. We developed quite a number of products, and we have soft launched this portal to share details of what we are doing, as well as documentation for you to try assess whether they are useful for you. And as well as the recording for this webinar will be published on this developer page. So please do join us at the developer portal. Next, I'll just pass it on to Gina to hand over to our colleague Gina. Thank you.
Thanks, Karen. Yeah. So I just want to shout out to the community during this difficult time. There are many different talented people out there who might be keen in making a difference to GovTech. So if you know any of your friends or your contacts who's keen in making that difference, please share with them. So you can scan the QR code for more details. Yeah, that's all I have for you. Thank you.
Okay. Alex, do we have more? Yeah, so if you can do feedback to us, and yeah, maybe we can still take one or two questions. Let's see. No, I think the presenter will still be around to answer some of the questions. Right, we won't be closing this channel so soon. Okay, so I think with that being said, right, again, thank you everyone for attending the meetup. I only just have one more announcement for you. This is not the June meetup. We still have another meetup for June. This is a surprise I have for the DataScience SG community. So do look out for it on the Facebook page. If you're from the StackX and would like to find out a bit more about DataScience SG, please go to Facebook, right, and look for DataScience without space and SG. We are over there. So do join us if you have not done so. Oh yeah, okay. Thanks for the spotlight. So in any case, thank you everyone for attending. If you want to stick around and ask questions, please continue to do so at the Q&A. If not, enjoy your dinner if you haven't. If not, have a good evening. Okay, thank you. Thank you everyone.
There are some people that have raised their hand.
Oh, hold on.
Guru.
Oh, three people. Guru, okay. Guru, would like to ask your question then? You probably have to unmute yourself first. Guru? Okay, never mind. Joseph, would you like to pose a question? Okay, or accidentally click on the raise hand button.
Okay.
Okay. Maybe we can take a few more then, since we still got 80 over people.
All shy.
Could you describe more on how was the accuracy of the models calculated? Who projects? Okay, we are both projects are talking about models, all right? So which project would that be? Maybe I'll get both the speaker to talk about their accuracy of the model then. Maybe Bertrand would like to go first.
Yeah, so basically, to calculate the accuracy of our models, we use the F1 score metric that I had described during our presentation. So we typically will calculate that on a per intent basis. So basically, if the chatbot has like 1,000 intents, there will be a F1 score for each of those 1,000 intents, as well as an overall F1 score for the entire chatbot. And typically, the work involved in the chatbot retraining and annotations process that I had talked about is the reclassification of wrongly classified real-world user utterances. And that will actually be the process that helps to improve these F1 scores on a continuous and ongoing basis.
So especially for VigilantGantry, so what our metric is actually really simple. It's basically like within 2 seconds, right? Do we get it correct or not? So the reason being is actually we are quite confident, like the usual YOLO, YOLO for people detection, the face segmentation, they're actually really, really accurate if you're looking square to camera. So what we're actually looking at is like within 2 seconds, is it a correct hit? Is it correct? So if you're covered within that 2 seconds, can within 2 seconds the tree algo detect whether it's covered? So we actually use that metric, right, to do the optimization. Yeah. So one of the interesting thing is actually it's not I think for vision problem, right, it's actually quite not a very, it's actually I would say that it's having dealt a bit in NLP, right, it's actually quite an easy problem to solve. As long as you got the right frontal image of the face, right, usually it's there. But for VigilantGantry, the problem is another one that we want to really optimize. It's more of the optimization, because you'll feel very irritated that you have to wait in a gantry for 5 seconds. Yeah.
One more question now for Delon. I think this is from Kai Wei. Besides data augmentation, right, do you need to collect more data that are specific to the IR cameras? Most of the COCO images are not taken at high angles. My experience are these models are sensitive to the distribution of the input data.
Yeah, that's actually a very good question. COCO data, actually, you're right. It's all frontal. It's all very nice. It's basically your face looking straight at the camera. So if you have a CCTV view, right, everything will be distorted. So actually, we take another approach. Rather than collecting more data, right, we do a warp. So the image, right, instead of like a frontal image, it will just be distorted. This is something that the CCTV is looking at. In terms of IR cameras, for the VigilantGantry deployment, right, most of the deployment is in the place of well lit. So we don't really have a dark image, because the place that we deploy are actually in lobbies, and lobby is actually where the security guard is. So you have to be very well lit. So for at least for that problem, right, we do not encounter the need of using IR cameras or IR processed images.
Okay, Delon, probably one more question. For fine-tuning an off-the-shelf model for a classification task, how do you estimate the order of magnitude of data required, assuming you can use data augmentation techniques?
Okay. So the model answer is as much model as you can get within the time frame that we have. So lucky for us, right, COCO data set or your ImageNet data set, they are in the thousands, 10,000. So we actually use that to train to have a good model. So in terms of the number, is I think it's sufficient if you use those publicly open data set.
Okay. Dylan, also one more question for you. I think this one will be interesting. How accurate or sensitive is the detector in terms of the placement of the gantry in open space, and will the heat or cool air affect the reading?
Yes, the answer is yes. Reason being is we actually deployed a VigilantGantry in a semi-outdoor environment, and it's really, really difficult. Okay, so there are actually two parts. So firstly, if you think about a thermal camera, right, most thermal camera requires a black body radiation. So you need a thermal camera black body radiation to really find the best, then you are able to minus off the surrounding temperature. So for outdoor environment, it's true that a thermal camera doesn't work as well. Hence, actually, so what we learned that actually the solution having outdoor is actually really challenging. Hence, actually, we make sure that we are actually using off-the-shelf solution because all these thermal camera has to go through certification. Hence, we actually we do not alter the input. We take it as what it is. So I think you have another question is gantry in open space, heat, cooling. Actually, one of the interesting thing, right, is we try to deploy in a semi-outdoor. It's actually pretty hot, so actually it affects my performance, the performance of VigilantGantry. So imagine we are running off a laptop now. So imagine if you do it 24/7, running maybe 70-80 degrees the GPU, right? So you throttle. So actually, in terms of accuracy, I don't think it makes so much in terms of the vision problem, but it's really basically the hardware, the computation problem. It does make a difference if you put it in an outdoor or semi-outdoor environment.
Okay, I think we'll take just one last question already. I think so quite a long day for the speakers as well. So just one last question. So in the private sector, so this is a general question to the speakers. In the private sector, right, online experimentation, also known as A/B testing, right, is used to test new models or features before rolling out. To what extent are government data products A/B tested live before roll out, and is there a team that specializes in that particular area? Or maybe let me rephrase this out. How would maybe GovTech sort of do testing and all this, right, before they roll out? Before they roll out maybe certain features or certain products.
Yeah, so on the Vika and chatbot side of things, the way that we do testing is we typically before we release the product to all the government agencies, we typically identify a handful as pilot agencies that we'll partner with to do like a sort of beta test of our product and give us feedback that we will then incorporate into the product before we roll it out to all the agencies out there.
Okay, Dylan?
Yeah, same answer.
Okay, same answer. Okay, Ken. I think with that being said already, I think that should be all. Thanks to the 60 over who still remain to listen to the Q&A. So with that being said, thank you very much. Thanks for sending the thanks over the chat as well. So with that being said, thank you, Delon, thank you, Bertrand. Is Cheow still around? Thank you, Cheow, if you're still around. Okay. Thanks everyone.
Thank you.
Thank you.
Bye.
Bye.
Bye.